The section 5.2, we're going to talk about network addressing and a little more about protocols. The TCP/IP, that's really a protocol suite. It includes lots of different protocols that allow us to, from our device, be able to communicate from our access device, whatever it might be. You know, this could be a phone, a PC, you know, it could be a laptop, it could be all kinds of things. Okay, and then we have some type of connection into the intermediate devices. Okay, and we talked all about those. Those would be, it could be an access point, could be a switch, somewhere's in there are routers, it could be a cable modem connecting us in. And so we can think of those intermediate devices as being in the cloud. And this protocol nowadays allow us to move through that cloud back out to another device that's also accessed. And this could be some server somewhere where we're getting, I don't know, eBay. Maybe that's eBay, and we're getting the prices on some products from eBay. Or it's Facebook, or it's Google, or it's your bank, or it could be. So all those places, when we communicate through a network, allows us to do this. Now, the most typical one we use to communicate through is, you know, that we're familiar with, is the internet. But lots of companies have networks that communicate not through the internet, but through their own companies and through service providers that allow them to connect. What moves through these networks using TCP/IP are data packets. It takes your data, you know, what you're sending. Let's say it's a URL. You need to get some information off of, I don't know, you're going to order something from Best Buy or whatever. So you have a URL and you type it in, and it moves you from, let's say, your phone here in through to Best Buy, to their access equipment, you know, to whatever they have, some type of server sitting there with all the information you need. Okay? So that URL is made into a data packet. Okay? They take and they put, before it leaves your computer, it adds some addressing and some more addressing. This is known as encapsulation. We talk very little about it in this class, but we will mention it. So there's some addressing, and then it takes off and it enters into this intermediate equipment, and all those things, switches, routers, and so forth, they use this addressing plus other information in here like specific protocols, and they move that information to wherever it needs to go. Now that move, years ago we had circuit switching. Nowadays most of that communication is packet switching. It pushes the packet into this inner network, and then it finds the best path through. Those paths are preset, but they could change quickly by the internet changing, you know, a new path created, or a line is cut, so it's got to go another way. Okay? Which is really a cool part of this protocol. So based on the addressing, it pushes the information through. So this URL hits a server somewheres, and that server then sends back the web page information. It comes all the way back to your device. Again, finding the best path through. And what it does, it uses the addressing to get it back to your device. That whole thing is known as packet switching. Circuit switching is like the old phone systems. Let me circle that right here. They're like the old phone systems where you create a circuit. We still do that. You create a circuit between these two locations. You got this location, and you create a path to connect between those. That's circuit switching. It would be like years ago when you made a phone call. You know, you had a phone here, and then the operators or the switch equipment would switch you over, get you on a line to a phone in Nevada or somewheres. Okay? And you'd have a circuit between those two. Just so you distinguish the difference, because nowadays it's packet switching, and those packets can move all different ways to get between the two locations. Now, I'm going to move this up. And finish up here. Okay. There. Now, let me continue. I'm going to talk about addressing. It's really not complicated. People could make it complicated, but it's not. Okay, so let's take physical addressing first. Media access control. That's where the term MAC address comes from. It's also called a physical address. There is a number in every device made in the world. Okay, the vendor makes the first half of the number, and then, the first half of the number is assigned to the vendor. That's assigned, and then the second half of the number the vendor makes. So that makes it unique. Like when Hewlett Packard are making their computers, they'll use a number that they have available to them here, and then they'll uniquely make these numbers. And it's called a MAC address. So every device has a unique number, whether it's your phone, your tablet, your PC, whatever. Anything connected into the network. Okay? Right? And you can connect in either through a wired or wireless when you connect in. Okay? Then devices get an IP address, which we call a logical address, and that has to do with what network you're on. Okay, so for example, the PCs at the college, they're pretty much use the same similar IPs all the time. But if you take your laptop and you walk into McDonald's, they will give you an IP. They'll give you an IP that is connected to a network they're connected to. So that's why we say it's logical. It's not set in your device. It can be, but typically it's not. And they use a protocol to get you a logical address. And that's then the address you use on that network wherever you're at. Another example, you'd come into NIACC and your phone would get an address. Now, those addresses that you're getting, I'm going to come back down here, those are typically a private IP. That's an IP that cannot be used on the internet. Okay? Now, before you get too bent out of shape about that, it's not a lot to worry about, but there are a whole set of them. Okay? 192, 168, and you'll see a 172, like 16 or something, and then a 10 dot something dot something. They're private addresses, so they're assigned to private companies. And as long as they use it within their company, it's fine. Or your little modem at your house, your router connected to your modem, could be all one device. It gives you a private address. Okay? Then, if you're going to go out to the internet, somewheres that has to be converted to a public address. Okay? And public addresses are used on the internet to move traffic through. Okay? So, and they're designed, they're blocked off and designed to be very efficient. They're split up into parts to be a very efficient way of moving information through the internet. So what actually happens, this is really important, so if you're getting a private address, like on campus, like at NIACC, that private address then is converted to a public address if you go out to the internet. I'll explain that more in a little bit. Okay? Alright, the next thing, domain name services. It would be too hard to remember all these public IP addresses. Okay, so an IP address has digits, and we're going to look at an example of them a little bit later, but here would be an example: 207, 165, 226, 184. That address I have assigned to a server on campus. Okay? That's assigned to a server on campus. It's in my office. It's in my office. Nobody else in the world or on the space station or maybe on Mars, if you watch that Martian movie, they can't have that. That's assigned to me. And that is a public IP address. Nobody else in the world has it. So you can be anywhere in the world and you can type in that address and you would come to a web server in my office. Because that's the only place it can go. Now on the internet, it's really cool because part of this is assigned, part of this, like this whole part, is assigned to NIACC through our ISP. So anybody has a number like that, it's going to come to our ISP, and our ISP, which is the Iowa Communications Network, is going to send that to NIACC. When it gets to NIACC, they know a certain group of these numbers are being used over in the area I work, the IST area, or the Information Technology area, it's now called. All right? And so that's how that works. Crazy. So now we can give that a domain name. For example, I bought the domain name Dirksen Education. Let's see if I can write it here. DirksenEducation.com. And I got that. I bought it. That's an EN in there, DirksenEducation.com. Nobody else in the world has that. Or on the space station or, on Mars or wherever. And so what I did is I pointed that at this address. So when you're at home, you could type in DirksenEducation.com. It'll get converted to this address because of DNS, domain name services. And then this address will packet switch. Remember up here we talked about packet switching? Way up there. It'll packet switch it through the internet and get it to my server. And then my server will see your IP address, which would be the IP address that's used for your service provider. And so I'd send it back to your service provider, whoever that is. Let's say it's MediaCom in Mason City. Then MediaCom will send it to your house using a public address. When it gets to your house, it'll be converted to a private address that's in your computer. We're going to go through that one more time. Let me finish up here. So domain name. I made a domain name right here. Also, I have Michael Dirksen.com, and that's pointed at a particular IP address that takes you to a website that I pay for services on the internet. All right, so let's finish this up with all right. So now let me diagram this out. Okay, so let's say here's the internet, and the internet has all these routers and different providers. I'll talk more about this later on, and they're all interconnected, and eventually then we have ISPs, internet service providers, and they have a block. They have a block of public addresses that they dole out. Okay? So let's just say here's your ISP, or here's my ISP, MediaCom. Okay? And they're connected then to an intermediate device, my cable modem, which is then connected to my little router in my house, which is actually a pretty nice one. And that's doing wireless connections to, we've got a laptop's actually my wife, we got our phones, and etc. I got a tablet, and so those are connected. And it's also connected wires to some a PC, it's connected to our TV, and so forth. Okay, then I have a cable connecting here. So these devices here all get a private IP to use. Okay? And so it could be the same private IP as at your house. Then there's a network address translation, converts it to the IP assigned by my ISP. Okay? So then when it leaves here, it has a public IP. Okay? Gets it right here. It has a public IP. So all these devices in here, all these devices could be on the internet at the same time. They send their information out, okay, into the internet. It goes somewhere. Let's say my wife is going to Pinterest, okay, and then it comes back, and then her laptop, when it comes back in, it uses the same IP to get back, the public IP, because it only need one because it's all coming back to the same place. When it hits Mediacom, they send it back into our cable modem, and when it hits our device right here, that device is smart enough then to send it to my wife's laptop based on a physical address of her laptop, which is unique, right? All physical addresses are unique. But media access control. Isn't that a good name? Media access control. And controls how you access the media. Here it's wireless for her laptop. And it could be wired. She can plug it in too. And so that works everywhere. Okay? So you can have your own, however you got it hooked up at your house, and you have private addresses there. You maybe didn't know this, but you have private IPs, and we'll look at those. But as soon as you connect out, it's converted. Before it can go into the internet, it's converted to a public. And that could be just one public. It's all it needs. Even if you have 100 devices in here, it doesn't make a difference. It only needs one when it goes to the internet because it's going to come back to that same ISP. It's going to come back to the same ISP, whoever it is. And then they are smart enough here. They have a router here that knows to send it to your house and not somebody else's. And the same thing's true at NIACC. We have, probably 700-800 devices internally, maybe more than that, connected with private addressing. But when it goes out, it's given a public address to use to go through the internet. And NIACC actually has a number of public addresses it can use. It has different public addresses so you can get in to different servers. For example, when you come into Angel from the outside, that has a private address matched up with a specific public address. And that's why they match. We'll see more examples of that in a little bit. And that's it.